Hi everyone. So in this video, I'll teach you about something called the difference of two squares factorization. And it's basically a method for factorizing expressions that can be written as a difference of two squares. So the factorization looks something like this. So a squared minus b squared equals a minus b, a plus b. And you can actually check that that's the case by expanding the right-hand side. So a times a is a squared, a times b is ab, minus b times a is minus ab, and then minus b times b is minus b squared. And then the ab's cancel, and you're left with a squared minus b squared, which matches the left-hand side. So whenever you have a difference of two squares, it can always be factorized as this expression on the right-hand side. So let's try applying this to a few questions. So for example, factorize x squared minus 4y squared. So we start by writing each expression, each term as a square term. So this one's already a square. And then 4y squared is actually 2y all squared. And then we would just go ahead and apply the difference of squares factorization. So if we write it out again, we can see that this is the b term. So that would just be 2y. That's b. And then this is the a term. So it would just be a minus b, so x minus 2y, times a plus b, x plus 2y. And that would be the factorization for this expression. Factorize 25x squared minus 81y squared. So we can see that they're not written as squares because we have something times a square. So we need to write each term as a square to begin with. So 25x squared is 5x all squared, and 81y squared is 9y all squared. And then we can just apply the difference of squares factorization. So 5x minus 9y, 5x plus 9y. Okay, let's do a few more examples. So 121, I'll just write factorize. So 121x squared minus 9y squared. And then we'll try doing 16x squared minus y squared. And then we'll do x squared minus 16, or let's do 49 y squared. Okay, so the first one is 11x all squared minus 3y all squared. So it helps to know your square numbers, by the way. So you should really be able to recognize that these are square numbers. And the same goes for this and this. And then that would become 11x minus 3y times 11x plus 3y. For this example, we can see that this is 4x all squared minus y squared, and that would become 4x minus y times 4x plus y. This one is x squared minus 7y all squared. So that gives 49y squared. And that becomes x minus 7y times x plus 7y. Okay, let's do some harder examples. How would you factorize something like 3x squared minus 75. So we can see that this doesn't become a square number. So we can't write it as a square. And this also isn't a square number. So we start by taking out the common factor from both terms. So that would become 3 times x squared minus 25. And then we can factorize this expression using difference of squares. So it would just be x squared minus 5 squared. And that becomes x minus 5 times x plus 5. Okay, let's try this example. So factorize 5x squared minus 80. So again, we can't write this term or this term as a square number, but we can take out a common factor of 5. And then we can just use difference of squares from this expression. So it would be x squared minus 4 squared, and that becomes x minus 4, x plus 4. Okay, let's try a few more examples. So factorize 2x squared minus 200, and then 3x squared minus 27, and then 98 minus 2x squared. So the first one becomes 2 times x squared minus 100, and that becomes 2 times x minus 10, x plus 10. This one is 3 times x squared minus 9, which is just 3 times x minus 3 times x plus 3. This one becomes 2 times 49 minus x squared, and that simplifies to give 2 times 7 minus x, 7 plus x. And notice the order for this question, by the way. So because the 49 is first, and the x squared is being subtracted from the 49, we would write the 7 first, and then we would subtract x from that. So 7 minus x, 7 plus x, not 7 plus, not x minus 7, x plus 7. That would be wrong.